Hello, today we're going to be talking about solving one-step equations. This is section 2 in our book, and you're going to find it on pages 83 to 89. Now, we have, or you have, I should say, talked and solved about solving one-step equations last year, but this year they're going to make the problems a little more difficult. They're going to look different, but I guess the goal today is to get you either comfortable with them or to get you to understand that you're really still just doing the same things. So let's get started. So solving by addition and subtraction. So what you saw last year, these basic problems, most of the problems you did last year were, what you always see. The variable is all the way to the left. It's simple addition or subtraction. So in this case, in order to move this positive 5 over to the right side of the equation, we're going to subtract 5 from both sides. The one thing I always try to stress to students is simply the fact that my best students always, if they're moving the 5, this 5 here, they actually start, like if I back up, they start writing underneath that 5, minus 5. Then when they drag their hand across the paper to write that one, it actually feels like you're moving the 5. So I think that's like kind of two ways of learning. You're kind of understanding that this gives you 0, so it cancels out, and you're actually physically moving the number. I think that helps kids out. And then we just make this subtraction. 9 minus 5 is 4. All right. I didn't flip-flop the x or the y. I just brought the equal sign down. I shouldn't say x or y. I didn't flip-flop the x to either side of the equation. I dropped the equal sign down. And then the same thing in a subtraction problem. So we have x minus 3 here equals negative 4. This may be a curveball for some of you, but we just got to get better at adding, subtracting positive and negative numbers. But in this case, I'm going to add 3 to both sides. Again, kind of starting with the number I'm moving and then doing the second part here. And then negative 4 plus 3. This is a subtraction problem. 4 minus 3 is 1. And the bigger number is negative, so our answer is negative. All right. Now, that's what you're used to seeing. Now, how can they change that up this year? Well, these can be maybe slightly harder for some. So the first thing, and I saw this in our quiz last week, when I led with a number, all right, what you have to understand is this is actually positive 4. And in order to cancel this out, I need to subtract 4 from both sides. I don't need you to write this in, but you need to be aware that this sign, and when there's nothing written, it is positive, that you're going to do the opposite. Positive 4 minus 4 is 0. That's how we cancel out in addition subtraction. And then I do the same thing to the other side, bring everything down, and we get x equals 3. So I did see some mistakes on this. I believe on the quiz it was r plus 8, and you had to move the r over. And many of us added r to both sides, but you should have subtracted. All right, so again, we have to understand that's positive, which you probably do, but the opposite's negative. And then this problem, and we've discussed this in class as well, that when I make this move here, I'm subtracting 16. So not only is the result going to be something that may make you, hesitate for a second, but also that our x value is on the right. And that doesn't change anything. So I'm still going to subtract 16. Again, I'm starting with the number I'm moving. I'm going to do it from both sides. And this one's not bad. You're going to cancel these out just automatically because that's what you're used to doing. Hey, I did something underneath it. It's going to cancel out. But then this might kind of freak you out a little bit. But 16 minus 16 is 0. That's okay. 0 is just a number. So it can be an answer. So don't let that fool you. You're actually getting the same result here. We're just not writing it down because x plus 0 or 0 plus x is still x. All right. We just don't have to write it down. But here you have to hold something on the left side of the equation. And so you have to have a placeholder there. And this happens to be 0. All right. Now, another one. And this kind of goes back to our chapter 1 stuff here, where before we do any algebra, before we do any of this moving numbers around the equation, we need to simplify the equation first. So what I see a lot of students do is they think they're going to add 3 to both sides, which would make the answer 8, right? But 8 minus negative 3 would actually be 11 if we checked our work. So what do we got to do here? Well, we can think of it a couple ways. Subtracting a negative is really adding. The way I kind of always looked at it when I was your age was a negative times a negative is positive. So this is really x plus 3. Or you could distribute, right? You're distributing into parentheses. So negative times a negative is positive. That will get rid of these parentheses. And so that's what we're going to do. Simplify first. And now it becomes a problem that you saw in the last side where we're just going to subtract 3 from both sides. And we're going to get 2 equals x. Notice in these two problems, I didn't flip these around. X was on the right. It finished on the right. X was on the right of the equal sign. It finished on the right. You don't have to flip them around. When I see kids starting to do that, that's a big red flag for me as a teacher, because I feel like you're not quite really understanding how all of this stuff is working, and you're just kind of putting numbers where you feel like it. So this is totally fine. I would 100% accept that answer, and I don't expect you to write it as x equals 0 or x equals 2. All right. Now, if you did that, I'm not going to mark you wrong, but I don't expect that. I think it's neater when you just bring everything down. All right, so let's move on to the second part, solving by multiplication and division. All right, so what you saw last year, basic problems, right? Doesn't get any easier in this. 3x equals 9. We're going to divide both sides by 3. Again, starting under the number I'm moving and then going to the other side. And we really don't do this step until all of the addition, subtraction, and the equation is done. But since these are one-step problems today, that's always going to be the case. And then the other thing I noticed in that order of operations problem from the quiz is a lot of people thought this was 0. 3 over 3. I think on the quiz it was 16 over 16. A lot of people put 0. This is 1. So canceling out in multiplication division means canceling out to 1. 3 over 3 is 1. 9 divided by 3 is 3. And I get my answer again, one step. And then maybe this is troubled some students in the past couple years when we first get into this. X divided by 4 equals 3. Kids aren't sure how to write this, how to actually show their work. But what I need to do here is the opposite of dividing by 4 is multiplying by 4. It just looks different, but it's really no different here. I got 3 in the numerator. I got 3 in the denominator. It cancels out to 1. And I did the same thing the other side. Same thing here. I got 4 in the numerator, 4 in the denominator. These are going to cancel out to 1, leaving X all by itself. All right, whatever I do to one side, I have to do to the other. These are going to cancel. 4 divided by 4 is 1. Bring everything down, bring the X down, bring the equals down. 3 times 4 is 12. These are the basic problems. All right, now there's a whole bunch of curveballs they throw in on this part. Let's take a look. The first one. I'm actually going to make this a two-step problem before I show you using the reciprocal, just because I think reciprocal is kind of a trick. And, you know, a lot of kids just end up putting this stuff in their calculator. 4 divided by 2/3, which is not going to help you when we change all these to variables. So we have to know how to actually do it. So I'm actually going to make this a two-step problem. The first thing I want to do is I want to move this 3 over to the other side. It's being divided, so it's divided by 3. So I'm actually going to multiply both sides by 3. These 3's are going to cancel out. And I got 2x, 2 times x, 2x equals 12. And now it becomes a problem like we had last time. Again, this is really a two-step problem. I didn't want to show you the trick yet. I want you to understand how it all works. All right, so there's one. Just a simple, you know, a one-step problem that we're going to kind of turn into two until you get comfortable with this. Now, here's one here. Again, we have the variable on the right, which is a little different. We have a -2 in the denominator. So we don't have to multiply by +2. We aren't really canceling this out by addition subtraction. We're canceling the negative out by multiplication, which means 2 negatives make a positive. So I have to multiply both sides. Oops, see, I already broke my rule. That guy should have been up first. We're going to multiply both sides by -2. And the 2's are going to cancel out. And the negatives are going to cancel out. And I get -2 times 7 is -14. So negative times a negative is positive. So that's why I end up with positive x. And I also broke my other rule here. I should have had this as -14 equals x. So I'm going to go back and fix that later. All right. Now, a couple other things we have to do. Here's one. This always trips kids up. This -x/3. So the negative's in the middle. It's not both -x and -3. It's one or the other. But when we want to solve for x, and there's actually an error here I got to fix. I'm going to do that real fast. Boom. Boom. There we go. All right. So there we go. I'm still going to multiply both sides by -3. And again, the negatives are going to cancel out. The 3's are going to cancel out. And I'm left with x equals -30. All right, again, another quick hitter. Just know to cancel that negative out, you just got to multiply by another negative. To cancel out a 3 in the denominator, you got to multiply both sides by 3. All right. Now the last one, this is probably the last trick you're going to see in this assignment. Anytime you have a mixed number, I'm going to want you to convert the mixed number into an improper fraction. So we're going to take the denominator, We're going to multiply it by 2, and we're going to add 1, and that's my new numerator. So 3 times 2 is 6, and 6 plus 1 is 7. So this becomes 7/3 x. 4 equals 7/3 x. And now I'm going to show you the one-step way to solve this problem. So instead of multiplying by 3 and then dividing by 7, we are going to multiply by the reciprocal. So the reciprocal of 7/3 is 3/7. So I'm going to multiply this side by 3/7. I'm going to multiply this side by 3/7. Now these 3's cancel out. These 7's cancel out. 3 divided by 3 is 1. 7 divided by 7 is 7. So these guys go. And I'm left with x on the right. And then here, I'm just going to multiply 3 times 4. The numerator times the whole number, because this is really 4 over 1, right? And so it's just numerator times numerator. And that's going to give me 12/7. And this doesn't simplify, and I do not need it to be a mixed number. I prefer improper fractions. So leave it as an improper fraction. And that's kind of what you're going to see today. So a lot of review, but also a lot of little mistakes that kids make with some of these smaller details. So again, watch this video as many times as needed. If you like what you see, please hit subscribe, and I'll see you guys tomorrow.